بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله. Uh, my dear students, as I mentioned in my announcement that I have uploaded on March 10, that starting week 9, we will continue delivering our classes via Blackboard. The materials, which is PowerPoint presentations, basically, and if there is any other supporting material, will be also uploaded to the Blackboard week by week. You will need to click on the specific week and try to read the materials there. Everything will continue the same as in the class. Delivery of the materials will be through recorded videos basically and recorded PowerPoint presentations, and if there is any explanation, we will be also explained in these videos. If the Blackboard continue to work properly, then please keep checking the materials week by week. And if the college continued and remains closed for many weeks, then assessment will be conducted online as well, like assignment 2 and also quiz 2, and we will see what happens. If you have any questions, please email me. This is my email address down there, zainm@ucj.edu.sa. I will be able to access my email at home. For this week, week 9, I will continue on chapter 5. In fact, I will finish chapter 5 because we have already started the first part of chapter 5. By the way, the midterm exam, which has already been printed, contains some of chapter 5 questions. So please cover chapter 5, the entire chapter, for the sake of the midterm exam. The same week we'll continue on chapter 6 and see what happens. Today I will start from this slide, which is the declaration order. Of course, the whole chapter we're talking about scoping, dynamic binding versus static binding. In this part of the chapter, we'll continue talking about scoping basically, in which we defined the term or the concept scope, and we said the scope of the variable is the location where the variable is declared, or the position of the variable where the variable is declared. So the word declaration itself in programming means assigning a memory location for a variable, and this variable, it could be a variable or a constant. It could be a value set on the same program, or it could be a variable that will be entered or generated from a data file. In all programming languages and scripting language, they use these variables, and we have covered the concept of a scope in details. We said that the scope of all local variables is within that block. All local variables will be considered, used, and accessed within the block. What is a block? The word block here can refer to a block of a function, which is basically between two parentheses, or a block of an if statement, or a block of a for loop, or a block of a whole program. So the block itself determines the item in programming where this variable is used. In C#, for example, the scope of any variable declared in a block is the whole block of the program, regardless of the position of the declaration in the block. But in other languages like Java and C++ and C#, C99, C++, and Java, these languages, the scope of all variables is from the declaration point to the end of the block. But this is also misleading, specifically if we see C# is a little bit diverting from this analogy by having the variable declared within the block can be seen within the whole program. You need to also realize that in some languages, including C# itself, the variable declared within a block, like a for loop block, will be seen like or used within that specific Look at this example here. The scope of this variable here, I, is going to be used only for this for loop, and for j is going to be used only for this inner loop. However, doesn't actually mean in any sense that this I could be used outside that block with the same value. If there is any variable declared with the name I or with the name j outside these blocks, is going to be different from these two variables, since you have actually assigned the data type for them inside the same block, like integer for this one and character for this one. Also, in some programming languages and scripting language like PHP and Python, the program structure will support the sequence definition of the variable. These languages, they will allow the declarations to appear outside the function definition, and in this case, as you know, it will be considered as global variables, like these three variables, item 1, item 2, and item 3. So item 1 will be seen by all these three functions, function 1, function 2, and function 3, and item 2 will be seen only by function 2 and function 3, and item 3 will be only seen by function 3, sort of from the point of declaration down. So these languages, they don't look forward. They don't look, up. The compiler will use the variable from the location, from the position where they declared down. So if the item 2 equals 6 and item 3 equals 6, which one of them is used by function 3? The number is 6 for both of them, but the memory location is different. The memory location for the item 6 seen by function 3 is actually either item 2 or item 3, since both of them are of the same value, but both of them are declared outside function 3 and on top of function 3. So the most recent one, which is item 3, will be considered for that function. If we check the memory location, we will see that the memory location for this value 6 is going to be item 3, and so on. So in C and C++, these languages, a declaration outside a function will specify that it is defined in a different location, memory location. In PHP, the scope of a variable will be implicitly declared in a function and is considered to be local to that function. And the variable implicitly declared outside the function, from the declaration to the end of the program, it will skip over any intervention function. So if there is any inner function or subprograms, this will not be using that variable declared outside these functions. However, these variables will be accessed by two keywords set for this scripting language, PHP, like globals, and the value will be read through the $sign, or the word global in lowercase without any symbol. If you look at this program, for example, you will see that the global variable 5 value 5 is seen or tested or accessed by the keyword globals, capital, and it is used as array within the brackets. So the value x is equal to 5. When my test function is executed right here, the value of x will be 5. When it is executed one more time, it will be accessed again and it will be incremented, of course, by this plus plus. The value will be 6. So if it is run again, it will be 7, and so on. Let me see this example here via the program I have created in PHP, which is the same program. I just added another call for this function. I can also try to copy and paste and see the effect of this access. So here for this one, for example, the program will give me 5 here, and then 6 here, and then 7 here, and then 8 there. Then let me see if I have this program here ready. Refresh. 5, 6, 7, 8. So if I change the value here to number 12, for example, so this will be 12, 13, 14, 15. So every time the function access this global variable, the value will be seen or accessed by this keyword, and it can be used in any mathematical calculation. This is a statement, by the way, which is an increment statement for the same variable global. The evaluation of static scoping, if you'd like to evaluate it and how it works well in many situations, specifically in PHP, Python, C, C++, C#, but it has a lot of problems. In most cases, too many access is possible, but it might result in inaccuracy, specifically if you have nested functions. You don't know which variable is used by which function. Like in the previous program, that this program here, where they have two different variables but same value. So this will lead to what we call confusion or inconsistency in the program writing, which is a writability problem. Also, as a program evolves, that means as the program continues, the structure is the initial structure is destroyed, and the local variable often become global. The local variable will replace the global variable. So also subprograms or subunits or subprograms, routines, procedures, blocks will become public or global rather than being nested items. And also this one will be a readability problem, specifically for programmers and designers who are editing the same program. Based on calling sequence of program unit, not their textual layout, temporal versus spatial. Temporal versus spatial, that means the calling sequence of the program, which function will be called before another, because sometimes some programs are called within each others, as we will see in the maybe next program here. So this will be seen as nested subprograms or nested functions, because here the function big calls function sub1, and function sub1 calls function sub2, and sub2 here uses the value of x. So the reference, if you talk about static versus dynamic in this scoping, in the static scoping, the reference of x in sub2 is actually the function big's value, which is this one, var x equals 3. But if you're talking about dynamic scoping, in which the variables keep changing or can be changed or modified through the program processing, the reference to the x in sub2, the same x here, will be the the value x equals 7, which is sub 1's x. So I would say that the most outer block is static and the outer block is dynamic. What is the most outer block? The most outer block is this one. It is static binding, while the just outer block, which is this one, the outer block, call it outer block, outer to this function, outer to this block, outer to this program, subprogram, it is dynamic. So if you as you go outer in nested subprograms, the more static scoping will be considered for variable declarations. Also, if you like to evaluate the dynamic scoping of the variables, some programmers will consider it as convenient because they will be able to use the same variable in different locations. But it has many disadvantages, like that, for example, as the subprogram is executing, its value, well, the variables of these subprograms will be visible and available to all other subprograms it calls. And that might result in what we call inaccuracy, specifically if you are using some floating point values for these variables. Sometimes also it is not possible to type check the variable when it is static, and also it results in readability problem. So it is not possible to determine the type of a variable if it is static, because the value will be entered or used during the program processing or at runtime, when you cannot predict which value the user will use, if it is a character or an integer, or if it is a string or something like that. So poor readability will be a problem. Sometimes programmers will avoid this problem by having a lot of comments, but this is only useful for programmers and designers. But for users, they don't see these comments or remarks, so it is actually a readability issue. Also, we need to explain the difference between scope and lifetime, because the scope and lifetime are sometimes very related, but they have different concepts. Because if you would like to define a scope of a variable, the scope of a variable is a region of the code where a variable can be accessed, and the location where the variable can be accessed. But the lifetime of a variable, it is the time period for which the value of a variable is valid, and as long as it is valid. The lifetime of this variable, it is validity time frame, but it might be accessed or it might not be accessed. So that's the difference between the two. You know, as you use a static variable in C or C++, when you use static the static keyword in C or C++, you are actually talking about the scope of that variable within these two languages. Then also we need to explain what is meant by referencing environment. The referencing environment of a statement is a collection of all names that are visible in the statement. All names of the variables visible in the statement, it is called referencing environment. Whatever we can refer to these variables, their names, their scope, their type, their values, and so on. So in a static scoping language, it is local variables plus all other variables in the scopes. In subprograms like functions and procedures, sometimes the variable is active if this subprogram execution started but has not been terminated yet, not finished. So we call this is also a referencing environment. In dynamic scoping languages, The referencing environment is the local variables and all visible variables in the active subprograms. Yani only the active subprograms. What is the active subprograms? An active subprogram, it is a program that has execution, has started, but not yet terminated. Uh, Here also I would like to talk about named constants, which is a variable that is bound to the value only when it is bound to the storage, because it's not going to be changing. It's always staying there in the location. It has good readability and modifiability, because if you'd like to modify it, just go and change the value in the program, and it is readable. All values are known. Their values are known in the program before it is run. I would like also to explain here that the binding of values to name constant can be either static or dynamic. Yani in some programs like C++ and Java, they are dynamic, but in C Sharp, for example, it has static constants. We can use the word read only or const for constants. This also can be used sometimes in C++ and C as well. So the values of this named constant that are defined by read-only keyword or const keyword are bound to compile time. Through the compile until the compile time, the value is not seen by the program. Also, the values of read-only named constants are dynamic bound, which is can be also changed through throughout the program. So every time you can just edit the value. I would like to show you here some example that I have written in this scoping. This program is a PHP program where it uses a lot of blocks, as you could see here. These variables, let me just show you this variable here. This variable m is declared as global variable, and its value is this one. The information you entered are wrong. This will be in blue color, as you will see here in this program. The information you entered, if you enter the wrong information, then it will be, that is what you see. Then if I would like to use this local variable for this block, it is a local to this block, which is if the outer if block. This is an inner if block, but this is an outer if block. The value of m will be a green color. This is wrong. So let me just save this file and see the effect of the local variable effect on this one, which is this one. This is wrong, which is this value of m. Now, if you actually kill both of these and try to copy the same statement and then just put it here and then change the color here to like red, for example, and see the effect of this block. Now there is no local variable, there is no I mean outer declaration for the variable m, and also there is no global declaration for the variable m. However, the value of message here, the message is this statement. This information you enter are wrong in red. So what this block is using the value of the most inner variable declaration, which is it is dynamically sorry, statically declared for this block. Which is this one. So it's using its value. So what happens is that the danger of this variables declared here in outer block or as a global variable here will destroy the values for this variable declared within the inner blocks. That is part of the scoping definition of these variables. So I would like to summarize this one to this chapter by saying that case sensitivity and the relationship of names to some special words will represent design issues of names. So we talk about whether the variable is case sensitive or not. In some programming languages, you see that case sensitivity is not an issue. In others, case is sensitivity is an issue, specifically in C, C++, Java, and so on. But in some procedural languages, like for example PL, SQL, and some scripting languages, this case sensitivity is not a problem. Also, variables are characterized by their sectables, like names, address, value, type, lifetime, and scope. All this chapter is explaining the difference between these different characteristics, which is name, address, value, type, lifetime, and scope. The last thing that we explained is the scope. Binding. What is binding? The concept binding is the association of an attributes with program entities. Also, at the end, we did talk about how you differentiate between dynamic and static variables, between explicit and implicit variables. Please review this chapter and also consider it for the midterm exam as well. In the next class, we will cover part of chapter 5, which is the next the class this week, and then which is uploaded also to the Blackboard. So I would like to stop here for this time, and then I will see you in the next lecture, inshallah. Assalamu alaikum wa rahmatullah.